Here at this point, then we can start with the first session. We can click on this link which says Seaborn Altair. That should open a new page called Visualization. So just to give a little bit of background, what we're going to try and do between today and tomorrow, and we'll figure out where things go. All of this material is available online. So if we don't get to some point, you can go back and redo bits and pieces of this on your own computer even. You don't have to do this SSH tunneling hop to do those things. And we can spend a little bit of time tomorrow to try and get Docker set up on your computers if you want to do that before you leave this workshop. That might be a good place to get things going. So we can spend a little bit of time tomorrow afternoon to do that. But for the moment, the goals are to kind of follow these notebooks. We'll talk through this, and somewhat down this notebook, we will run into things like this. Let's see. We'll see exercises. And the solutions to these exercises are in the notebook itself, but that would completely defeat the purpose of having a workshop. So their solutions are there partly to guide you if you get stuck. But the intent would be that you work on these solutions based on the previous few things we have seen. So that's how the general notebooks will get along. I also wanted to say we do a lot of things in this open space, and the primary language we use for a lot of these things is Python. So I know Eric had asked people to at least go through some introductory Python things a couple of months back. We're not going to teach Python at this point in time, but if you're really stuck with something that's just pure Python related, just raise your hand. I know there are a bunch of folks in this room who have studied Python. Learning how to deal with these things as opposed to clicking buttons in some program gives you a lot of power as you analyze data. Because unlike designing cars where the terrain of your road is known, you know that cars are going to work, neuroimaging and neuroscience is like designing the Mars rover. You know something about the terrain, but you're always going to run into trouble. And when you run into trouble, that's the time when those push-button tools fail you, because they were designed for some specific situations. And knowing how to deal with those tools at those points in times and how to adjust and adapt them is what's going to help you in doing your research. So that's why we sometimes learn to lay bricks, even though it's easy to buy an apartment and move into it. So what we're going to do is learn how to lay some of these bricks. That's the goal of the next few things. We're still not going to go down to the lowest level of things. You got introduced to NIPAC a little bit. We're not going to rewrite Recon All and FreeSurfer just because we can. Somebody has put in a lot of effort in creating those things. We will reuse tools that other people have created. But along the way, you will run into a lot of situations which are unique to your research question, where you need to build tools or work out tools. What we see over here are sort of basic building blocks that help you do things. The reason we're starting with plotting is that I don't know of a single publication where there's not an image in neuroscience. So at least getting to know how to plot things is a good place to start. This first notebook we will cover, and since we've spent a bit of time getting all of our setups going, we'll try to do this at a good pace. If you get lost, I really want you to place that sticky on so that you're not completely lost. Okay? But we will go through a few basic things. So why do we do visualization? And many pieces, that's how we live in this open world. We scavenge pieces that we use for various things. These notebooks and other things, they are being curated in an open space. Once you're done with these things, you're welcome to contribute back to them. Improve them. If you feel that one notebook was too hard, given the background that people have, create a simpler notebook that gets you adjusted to things. Or point to other notebooks or other resources that help you learn those things. So here we are making some assumption that you know basic Python, And you can follow along when I use the term importing package, that you know what that means. So why do we visualize things? As Tal says, starting off with here, to create very pretty publication quality figures. Or perhaps more importantly, to facilitate understanding of data. That's really the reason for visualization. I know sometimes it gets lost in the notion of creating beautiful pictures, creating pretty pictures. But you can achieve both with the set of tools that exist currently. You can create good quality pictures as well as facilitate understanding of data. The second thing is that depending on what you want to convey, there could be different ways in which you might take the same data, create different visualizations. So to have a set of tools that allows you to do that is quite important. And the good news is many of these tools, even with these lower level libraries, allow you to create publication level quality figures fairly quickly. So instead of trying to use Excel to generate a chart, you have 2 lines of Python code that does the same thing but is much more flexible. So it's easy for us to drop into our modes of, we know something, we do it. Here, we're learning something new, and it gives you a lot more power. At least that's what we think. Maybe all of you disagree with me, but hopefully by the end of this, maybe some of you will agree with me that we have slightly more power to do these things. And science is hard. Tools don't make science that much easier. It's still going to be hard. They just help you along the way to do certain things. So what about visualizing in Python? Python provides a wide array of options. How many people here are familiar with R? Okay, I see a couple of hands. So R has a lot of visualization features. ggplot is a fantastic package in R to do visualization. But since there are only a couple of people, one of the principles, at least I use in the work we do in our group, is that you use the tool that solves the problem at hand. You don't take a hammer to bang on every single nail. You can take one tool and try to do things. So if tomorrow I want to visualize something for which R is better than Python, I will use R to visualize that. And that's the kind of flexibility I think is important in the context of doing research, being able to use the right tools. I like the Python ecosystem because it has a wide range of tools that help me do research that I do. And we will get exposed to some of them along the way today and tomorrow. So 3 packages in Python. Let me try and extend. 3 packages in Python that are kind of important in the visualization world are Matplotlib, pandas, and Seaborn. Matplotlib and Seaborn are visualization related packages. In fact, Matplotlib is the core 2D visualization library in Python. Seaborn makes it easier to use Matplotlib to generate good quality figures. Pandas is like R's data frame, but since I only saw 2 hands up with respect to R, a data frame is a way of representing tabular or hierarchical index information in an array. So think your Excel spreadsheet, but instead of having 1 spreadsheet or 5 spreadsheet, you can combine those things into a data frame. And pandas is a library in Python that represents data frames. Okay, so as we go along this notebook, we're going to execute cells, and what that means is clicking on a cell so that this boundary turns green, and we're going to hit shift return, and it should make this thing become dark. I don't know if you saw it, there was a little circle over here that became dark for an instance, and then it became 0. You would have also noticed that this number over here turned into a star for a second, and then return the number. I can do this again. Shift, enter. That was very quick because everything has been loaded into memory, but effectively, this is executing things. And if you had noticed when I pointed here that this was a 1, this is now a 2, because it re-executes the cell, and internally in the notebook, it keeps track of each time it executes something, and the output reflects the sequence number of that execution. Okay. So what we're going to do here is we're going to pull up this data set, which is simply a CSV file. So everybody here knows what a CSV file is? Or a TSV file? Yeah. Okay. So pandas can read things directly off of web URLs. You don't need to save the file and open it up. You can directly point to a web URL and it can read it. And the other thing is that this file has missing numbers annotated as n/a. And we're going to tell pandas that. We're telling pandas that wherever you see this, consider it a missing number. What that internally does is it represents those cells with an and, not a number in numeric form, instead of a string, which is n/a. All right, so we will click on this. And it's going to take a second because it's downloading something from the web. But it's done, so we see the 3 next to it. And then what we're going to ask it to do is we're going to ask it to draw every column that has any missing value. You may not want to do this for actual research work. For the purposes of at least today's demonstration, we're going to restrict this table to only columns that have complete values. And then the second command shows me the first 5 entries of the table. So if I rerun this, it'll disappear for a second and then show it. So shift, enter, execute cells. We're at the point where we have these tables. Now you can see that it has a bunch of different columns. It has something called site ID, participant ID, DX group, age at scan, sex, handedness category, handedness scores, and so on. I think this goes a little bit more to the right. VIQ, PIQ, VIQ test type, PIQ test type, etc. Without knowing the document that comes along with this, which says what these columns are, it's hard to interpret some of these things. But we're going to at least use a couple of different columns because as a cognitive scientist, you kind of know what some of these things are. So DX group is diagnosis group. The above data set happens to be a data set from a study that involves patients with autism and individuals without autism. So diagnosis group 1 and 2 refers to one of those 2 groups. We don't know which one. And this is another reason why when you generate data, and we'll talk a little bit about this tomorrow, you want to encode information so that one can convey it when somebody reads something like this, as opposed to having to look up pieces of information elsewhere. So as you create your own data, think about ways to encode things where it's not just numbered. It would have been very easy to use autism and control as 2 labels for this. The reason many people refer to numbers is because their Excel thing doesn't deal with strings. It can't deal with categories as strings, so they prefer numbers and deals with it that way. But the set of tools that you have access to really allows you to do the same thing for sex. What's 1 and 2? I have no idea. I'll have to go look it up somewhere to tell you what 1 and 2 means. Handedness category, again, 1 and 2, I have to look up someplace to look at these things. But the best way to encode your data is to actually reflect these with the right labels that are standardized in some ways so that you can use them. Okay, so we have this table. We can look, instead of looking at that visual display, we can use this command called keys and use the Python construct called list to look at all the columns of this table. So I'm going to execute this cell, and it says, okay, this has all these column names. These are going to become useful. The one thing I want you to note for this particular data set is that age at scan has a space at the end. That becomes important because when we refer to these things, it's easy to miss this space. Right? When I look at this thing, I don't notice that space over here because it's just printing things out. But when I want to play with this data, then that space becomes important. Okay, so what we're going to do is, most of these exercises will typically involve copying and pasting and modifying. So all we're asking you to do over here is for you to load 2 other data sets. The URLs are over here, and then use the head command to display each one. So we're going to time limit things, partly because we want to move things along. We can always hit show solution, and that'll give you all the things that have the solutions in it. But to start off with, try attempting, just based on the previous cells, if you can copy and paste and get hold of this data set and display it. So it gives you some suggestions over here. First thing, load and filter the data. So can you copy the command that loads the data, filter it? All we mean by filtering here is that we're removing these NA values. So we're reducing it to columns that contain all the data, and then displaying it. This should be relatively straightforward to do based on the commands you have access to earlier in the notebook. So we'll give you 10 to 15 minutes to do this. If you can surprise me with doing this in 5 minutes, we'll move along much quicker. But this one should be relatively straightforward. And if you're really stuck, I shouldn't even use the term really stuck. If you're stuck, if you need some help, just put that sticky on. We'll come around and help you. And there are people in this room who know Python pretty well to do at least these steps fairly easily. So I'm going to give us still 11:40 to get this done before we move forward. But give it a shot. You can't break these things. Worst case scenario, you just reload the notebook and get up to that point. So try and see if you can copy, paste, and generate that table. The previous cells tell you how to do so. Okay. So in the Jupyter Notebook, each cell is a place where you can add your own things. So you can edit the cell over there and execute that cell. So you don't have to open anything else. You don't have to open Python somewhere else. You just directly add new things. And if you're not familiar with the Jupyter Notebook still, escape gets you out of cell mode, cell editing mode, into a view of the cell, so I can navigate. See, I can go up and down, selecting cells with my arrow. If I hit enter over here, it turns the box green, so I'm in an editing mode and I can edit things over there. And whenever you want to execute it, you hit shift enter on that cell. If you want to create a cell above and below, you can either use these edit things. There's a whole lot of commands that are available. We're not going to go into the details of how Jupyter Notebook works, but the basic thing is you can use this to write your code and execute it directly. So you can't open a new notebook because a new notebook doesn't have all the important things that are in this notebook. So if you start a new notebook, you have to scroll up and copy the import lines over it. But the general idea is that you don't open a new notebook, you just make changes in the notebook that you're using. Just one note that I'd like you not to save the notebook, because we are using a shared space for the notebook. Don't worry about it. I mean, all these notebooks exist elsewhere, but we didn't make multiple copies of these notebooks for every single user. We can learn how to do that later on, but for the moment, you can make changes to it. Each of you are running a unique thing, but if you hit save and somebody else reloads, they're going to reload that version of things. So if we look at the solution, which I can do just by clicking on this, we see that we're using exactly the same commands that we used earlier. The only difference we did here in this command is that we are not assigning the table to a variable directly. We are actually doing this operation called .drop ending on the reading before we assign it. It's just a simple Python shortcut to say read, drop, assign. And we're doing this for both variables over here. But we could have easily done it in 2 steps, which is what the previous cells did as before. And then the other 2 steps are trivially easy, which is just calling the head function on each of these 2 variables. Right? And you can see that this has read 2 different things, partly because this said this is from OHSU and this is from NYU. Those were the 2 different data sets that we were using to read things. Now we will not use these data sets for things. What we'll go through is kind of looking at each of these libraries and what it can do. So the first library we start off with is Matplotlib. It's your base library for all 2D plotting in Python. And it can do a lot of things, but it requires many lines of code to do it. So the first thing, very simple. We're going to plot age at scan, and remember that extra space that comes up over here. So we are indexing into that pandas data frame and telling me, give me all the fields with age at scan, versus if there wasn't a space, I can actually use the name of the column directly with this dot syntax. So I don't have to do the brackets. It's a space that makes it difficult over here and makes me do this. And I'm asking Matplotlib, the PLT function, to do a scatter plot. So it plots age at scan against verbal IQ. Then I say put an X label on, a Y label on, and a title on. And if I run that, oh, one more thing before that, which is the figure size. So I set the figure size in figure, and 10 refers to the width, and 5 refers to the height. So it makes a figure that's wide and narrow. And if I hit enter, it reruns it, and regenerates it. And I can't fit it into my window because I made it really large, so I'm going to make it a little smaller. And we see all the things. So it's plotted age at scan against verbal IQ and labeled the axes. Most of the time, people are generating scatter plots. So this is not hard to do. But we can do things like this. We can use just another set of commands to create a panel of figures. So there's a scatter plot here, a bar plot here, and a colored scatter plot over here. This color, in this particular case, is referring to diagnosis group. So it's taking each different diagnosis group and assigning it a different column. So let's go through the code a little bit for this. So as before, we are setting fixed size, but now we are using this command called subplots to say we want 1 row and 3 columns of figures. So 1, 2, 3, that's how it generates the 3 plots. And it gets some of these variables back. And then for these variables, so axes contains 3 things because we are asking for 3 different plots. Axis 0, this is Python, 0 index, it's not MATLAB, 1 index. We ask axis 0 to plot a scatter plot. And then we turn the axis off, which is why this plot doesn't have any axes. Right? So it allows us fine level control. The second thing we do is we compute the mean. This comes from pandas. So this group by function basically takes that data set and groups it by the values in this column. Remember, diagnosis group was 1s and 2s for the 2 different types of participants in here. So it groups it, and then for each group, it takes the verbal IQ column and computes the mean. So in one line, we have the means of 2 groups from that data set. So this is not going to be a pandas tutorial, but I would highly encourage learning about pandas. It's a very powerful package and library to do things. Yes?
Just really briefly, does pandas support more of those sort of deep layer chaining?
Could you speak up a little louder?
Yeah.
I have a HVAC system on top of my head.
I was going to ask, that seems like it's a similar syntax to the deep lawyer chaining that allows you to sort of separate out your analysis. Is pandas doing a lot of that stuff?
Pandas is doing a lot of stuff, and especially if you're familiar, I saw your hand was raised for R. So many of the things that data frames do, this is really Panda, the Python equivalent of data frames. So,
Okay, thank you.
yeah. Okay, so we've got the means, and we do a bar plot. So that's basically saying on this axis, do a bar plot where we're giving it the range and we're plotting the means. And we'll take a look at that plot in a second when we see how we set these X tick labels. So we're trying to set tick labels on this thing. And obviously it's broken. Right? I don't have proper labels for either of these things. But it did plot the bar plot properly. Now we can go through Matplotlib, get hold of handles and fix it. But we will get to an easier way to do this in a second. Matplotlib does allow how to fix this, but we won't fix this right now. And the final one, which we have over here, is simply saying, I'm setting some colors, blue, green, and red. Since we only have 2 categories, it's just using blues and greens. And for each group, and this is, again, using that group by function, it's getting each group, and for each group, generating a scatter plot on that axis for that group. So, very simply, you can generate a lot of things. So Matplotlib is quite powerful. It is the base library. Now, I have exercise 2, but we're also heading up on noon, which is when lunch comes. 12:30. Okay. So how about this? I give you even less time to do this exercise, because I really would like to get up to Seaborn before lunch. We are almost there. Or alternatively, we can leave the exercise for now. Right? We continue on, and we can come back to that exercise in a second. This exercise, again, much like the previous one, was going to be very simple. If you can parse out the previous pieces of commands in the cells, you can generate each of these things. We're asking to change figure size, which you can copy and paste and change. We're asking you to use the colors red and gray instead of blue and green, which again should be fairly straightforward to do. The opacity. So this is the part where you jump out of the notebook, out of Python, and go and look up a URL to see how you have different keywords that you can set. I don't memorize all of these things. There used to be a day when all of these things were in your head, and if you use it often enough, but the set of packages we get to use right now changes so rapidly and so fast that I don't memorize. I just open their documentation page, that's a different browser window, and I just use that to guide me in setting things. So what I retain are sort of conceptual pieces. I can manipulate every single dot and color over here. Right? That's my conceptual piece. I can manipulate every single tick. But how I do that, I open up the documentation page and deal with it. Label the axes and add a legend. So in addition to these things, what you can do is for this, so we are asking you in this exercise to take this plot, change the colors, change the opacity, and add a legend which says this color is this group, this color is this other group. Something that's useful in the context of a publication. With very few lines of code you can do that. But I'll leave that exercise for a second. The other thing is you can take code from the Matplotlib gallery itself, and that's one of the nice things about most of these visualization tools, is that you can go to their page and there are examples. And one of the nice things you can do with visualization is study examples of other people, how they have presented information. And each of these packages have a lot of examples of presenting different types of visualizations. And the thing is with visualization, it's not just the Python libraries. How many people here have heard of D3? I see a few hands. So D3 is a JavaScript library for visualization. It's something that's quite robust to a lot of things. And even though you may not know JavaScript to use it, although that would be fine to copy and paste some lines of JavaScript code to generate. You could use Matplotlib to generate D3 libraries, D3 figures, but you might use styles. You might use how they have presented the information and recreate it with something that you are comfortable with. And if that tells you that what I'm used to can't generate that, maybe it's time to learn something else. But it boils down to not saying I'm limited by my tool to generate the kind of visualization. I want to express this information in a particular way, and I'll find the best tool to do that. I think that should be the change in how you approach information visualization. So this is, again, I'm going to just run it, and it runs it, and generates a couple of 3D plots. We will get into 3D, hopefully, this afternoon after lunch, but this is just generating simple 3D plots. So what are the pros of Matplotlib? It provides low-level control over everything. But low-level control also means more lines of code than high-level control. It has a steep learning curve. Yes, you can generate simple plots simply and easily, and that gets you started and gets your juices flowing. But once you get to really nice quality figures, you have to do a lot of manipulation yourself. And that's precisely where these high-level interfaces kind of come in. And we're going to look at Seaborn as one example of a high-level interface to Matplotlib. I would say it's probably the current default standard. So for example, with a couple of lines of code, you can change whether you're generating a figure for your talk, your poster, or your paper. Simply using the set context. And again, you can use this link to look at how different aesthetics are set for different things. And all that does, so we can look at this plot that we had generated, comparing age and verbal IQ. These font sizes are kind of small for reading. You wouldn't print these out. And all we need to do is to set this context to be for a poster. I'm also setting a style called pastel, which changes the color choices. I'm reusing the Matplotlib commands over here. I'm not changing anything else. I'm mixing Seaborn and Matplotlib over here. And just to say that we can actually run this. This now generates this plot. Much easier to read. It's clearer, cleaner, better for a presentation like this than the previous plot. Well, the choice of pastel is questionable, but that was kind of explaining and demonstrating that you can change these colors as you're dealing with it. Okay. But with a single thing, you can also do things like this. So there's a functionality, and you will just look this up in a gallery of Matplotlib. So this is the joint plot function. We are saying use AJetScan with that space and VIQ, and then we give it this data frame directly as the data input. And we're basically saying don't compute a stat function on this. Otherwise, it would try to do a linear fit between those two things and even plot them, which, again, for some things might be straightforward. So let's do this. Let's rerun this. Okay, generated that. And now let's comment out what would have happened if we had done that. It reports the Pearson R over here. So it automatically computes your correlation coefficient and your p-value for this. So I'll run it without the stat, that Pearson R is not there. So we're simply saying suppress that information. And it's not just a Pearson R, you can set that stat function to be all kinds of stats you compute on this data. But look at this figure. So what's different now, this figure? Okay, we still have AJetScan and the verbal IQ. But I don't know how clear it is at the far end of the room. Okay, here says it's good. You can see these distributions. So these are histograms along those axes of these plots. One line of code. Well, two lines because you needed to read the file from somewhere. But that's what it takes to generate that. Again, I'll leave these exercises as a separate thing. So now we can get into slightly more fun stuff with Seaborn. So we can actually give Seaborn instructions to change the context of many of these figures. So this dictionary that we are creating says, I want to set the size of these circles. So this S equal to 100 sets the size. Alpha refers to the opacity. So if you look at these circles, when they overlap, you can still see the overlap. That's what opacity refers to. It creates translucent circles. Again, controlling all of this individually would be much more work for various things. But I'm still within about 5 lines of code over here. We can set the line width and the edge color. Okay. Then we use another function in Matplotlib called facet grid. Facet grid does something very similar. It plots facets across from each other, but it creates these multiple plots. So what am I asking it to do? I'm asking it to use sex as a column for this facet. I'm asking it to use the diagnosis group as the color of the scatter plot. I'm asking it to use set1 as the palette. And then I wanted it to plot 1 and 2, the hue order. So choose from the palette the category with values 1 as the first order and category with values 2 as the second order. And then for each plot, it's mapping this function, which is plotting the scatter plot for these things with those keywords that I said, and adding legends. So now I have a legend which says diagnosis group 1 and 2. I still have AJetScan reflected here. Note that it shares the same y-axis. So it takes care of a lot of things under the hood for you, which normally, for generating plots of this nature, you would have to do a fair bit of work. Still only 5 lines of code. So I'm going to execute this cell, make sure it regenerates things. And it's kind of nice with the opacity because you get to see where shared points are, right, which would be harder to see if I had set opacity to 1. Let me do that. You can do that very easily. Alpha equal to 1. Opacity is gone. So now it covers things up wherever things are posted. So simple changes that can be done. And we have a few more exercises. And then the place where visualization is moving, in general, not just in the Python world, is this idea of grammar of graphics. That you can tell things to draw pieces without focusing yourself on a particular language. So what the grammar of graphics does is something like this. So there is a Python package which deals with it called Altair. The grammar of graphics underlying library is called Vega, which deals with this presentation of material. And let's walk through this. So we're creating a chart using the data in this variable called subdf, where we're storing our information. We're going to create circles, so that's the marked circle, with opacity and size. And then we're going to encode these things. So we're going to say our column is going to be sex, so columns of figures. Our x-axis is going to have age at scan, and our y-axis is going to have verbal IQ, and the color is going to be with DX group, and then we can make the size of the figure be a certain size. Now, there is no particular language construct over here. This is kind of a language agnostic thing. Yes, this is written in Python, but what this generates, and the first time you run this, I'll let you know that Altair doesn't generate the figure. So you run it twice, and here it's created that same figure. So similar ways of generating the same kind of plot. What's nice about this, if I look at the bottom, it has export as PNG, which you can do with the other things as well. View source, and open in Vega editor. And the reason this open in Vega editor is important is that it's sending something called JSON, which represents the information that you're plotting rather than the language with which you're plotting that information. And see, Vega, the editor, created the exact same plot based on that information. So it's moving away from a language-oriented representation of information for plotting to a language-agnostic way of representing that information that generates the same kind of plot. And different languages now have support for different levels of Vega. Okay. So we've kind of gone through the basic plotting routines over here. And since we have lunch at 12:30, this might be a good time to finish those exercises along the way and test out different things that you've done. And then post-lunch, we can look at the next notebook, which is NiLearn, just to give you a teaser for it. This loads up. We're going to start off with using NiBabble as a way to read these files. We're dealing with neuroimaging files over here. And then plot it in various ways. So look at brain images of various kinds. And then this is the part which I'm hoping this will work. We ran into a few pieces of trouble, which is the 3D notebook. And I need to run this. A little bit of time to load. The way I know it's still working is because that circle that's next to Python 3 is still dark. So it's still trying to sense the computation that it's trying to send things. This is one notebook which obviously runs a lot faster when it's local because it has to send information. But I'm hoping I can give you a little teaser before lunch before you do those exercises. Still sending information. There it is. So that creates a volume render, an interactive volume render in the browser of a brain image. And we will play with various aspects of this in this notebook. But those are the three pieces we're going to cover. This is obviously much more exciting than the 2D things, but no paper accepts a 3D render yet. This is what you generate to post online so that other people can have fun with your data. But this is where it should be. I mean, there's no reason you take information that could be represented in 3D and presented in 2D. And we'll have some fun with this when we get to the notebook. So because there's a lot of data, this particular notebook doesn't save any of these renders as part of the notebook. You may have noticed that in the other notebooks you saw the scatter plots, the brain images, because it can save that information there. there's a lot of data in this, and the notebooks don't save it. But this is kind of a fun notebook, so I'd like to get to this as early as possible before we get to machine learning. But maybe we get back to those exercises, play with it. I think that's one of the key elements, that you're here to play with these things, ask questions, see if you can solve those. Yes, the solutions are there, but that's the easy way out to do things. See if you can force yourself, even if Python is unfamiliar to you, to say, I can copy and paste code, even if I don't understand things, and I can generate things. So that's the spirit of hacking. I can take anybody's code and work with it, even if I don't understand it. And as you get doing that, you suddenly realize all code looks alike. Python, MATLAB, R, doesn't really matter. And I think that's where you want to get to. You don't have to be an expert programmer to be able to hack with some code. But having some knowledge of this helps generating things, because you can start imagining how easy it is to generate these figures once you get a grasp of these things. Next time you need to generate a paper for a figure, you have a whole lot of tools now available to do so. And this is just a subset of tools. The main notebook, the introduction, so the intermediate and advanced things are coming, but it points to many resources. And one particular resource that I will highlight over here is this InfoViz thing. Hopefully it will load up. Information visualization is everywhere, not just neuroscience, neuroimaging. What this site does is goes through and talks about representation of information. And much like you have to learn not just the code part of it, it's also important to understand how to visualize information. And in that space, not only are there many online resources, there are a couple of books. Edward Tufte, if that name rings a bell to people, is a designer. And one of the images that audience March. It's so popular that my browser, which doesn't store cookies, this particular one, want to get there? 1 second. I'll just pull this up. This is an example of visualization which shows Napoleon's round trip to Russia with his army. And the width of this ribbon indicates the reduction of army size as he makes this trip over time. So information visualization is really about conveying an understanding of data. It's not just a scatter plot. It's not just a necessary requirement for publication. It's really about how you represent the information towards it. I would say in brain imaging, most of the time we do very silly and stupid and simple things. That's much better ways of representing information and conveying that information. And one of the things we fail to convey is uncertainty in that information. And that's one of the things that you have to think about when you're conveying information, which is how do you convey the uncertainty in the data that you have? Yes, images speak volumes, but they have to kind of also convey that we're doing science, we're not certain of many things. We're showing you probabilistic outputs, we're showing you uncertain outputs, and that has to be encoded in the information visualization. Okay, I'll stop there for now, go through the exercises of Notebook 1, then post-lunch, we quickly run through Notebook 2 and get through to Notebook 3. And we'll stop there for the moment. Notebook 4 requires us restarting the Jupyter Notebook, but I will give you a quick view because that one actually has the information. So this uses a Python package called MyAV to do 3D rendering. And I'll just show you the output at the end. So this is a 3D render. It's plotted as a 2D thing. If you were to run MyAV locally as a package, you get the full benefit of the 3D interaction. So you can create synced displays, you can do VRs, everything with MyAV. But MyAV is kind of the default 3D standard in Python. But the one we will focus on is this package called IPyVolume that's been around for all of about 2 or 3 months now. But it allows us to do these really nice 3D things that are interactive in the notebook, which makes it much easier as you're working across networks and interfaces. So we really want to spend some time with this and show you the power, at least in the brain science space, of using 3D visualization. But I'll let you do the exercises first. So this is a site that just gives access to T1 images primarily. But what I wanted to show was this visualization. So this is called a categorical coordinate plot. Each column is a different dimension. And if I can interactively select across dimensions, so that's like filtering and searching for things. So if I wanted to look at all the people who have MRI images, I would go to this first column over here. And select all the MRIs, and it shows I have 8,000 MRI scans accessible. If I wanted to select only the male figures over here, I could go and select the male figures. But I can also click on the sex variable over here, and it colors by categories. So it carries the category colors across the columns. So wherever it's orange, those are female individuals, and that shows that we have a fairly general distribution of age across male and female folks. But let's look at the About data, which has folks with autism. Now, among folks with autism, there are many more male individuals with autism than females. And you can clearly see that just by the coloring over here. So we're still on the sex category. Blues are males, orange are females. And if you look at the distribution on any other dimensions, it's mostly blues. So these are ways in which you can represent information that clearly conveys. Here we're not saying here's a number that says these are so many blues, so many males, but just the way information is represented carries the notion that there are many more males here than there are females. If one really wanted to find out how many there were, you would just select this, and it would say there are 948 rows of males, our data set, and 164 females. So you can also get that information. So this is an interactive plot, but the general notion here is that you can simultaneously watch 10 different dimensions of data in a single compact representation that would be really hard to do with a pairwise plot. So going back to the pairwise plot, let's go over here. The next thing we had was asymmetric violin plot. So if you've heard of violin plots before or have looked at violin plots before, most of the time they're very symmetric. It's a complete waste of space. They might be pretty, but representing the same information on both sides does nothing about the information conveyance. It's an aesthetic thing. The asymmetric violin plot is kind of nice because it conveys two different types of information on either side of the axes. So we're just looking at, again, at distributions of verbal IQ as divided by groups. So we're using sex as a variable, so each column represents one of the two groups. And the distributions on the left and right of the violin plot represent the diagnosis group, so autism and controls. So again, if you needed to convey information where you're separating out gender or sex and separating out diagnosis group, this is one way of representing things. So information visualization really is an art or a design rather than following a rule. You have to think about what information you want to convey and figure out the best way to represent that. What these tools give you are the basic building blocks of doing so. And the final exercise we have over here is using the Altair gallery to do a binned plot. Those of you who use GitHub for doing various kinds of development have seen something like this. It's called a timestamp when people are coding on a project, because every time you commit things to GitHub, it has a timestamp of when you have been worked on it. In this particular case, we're just looking at verbal IQ as a function of age, but instead of plotting it just as verbal IQ, we're binning verbal IQ. We're saying how many records are there of verbal IQ I look at just this one, between 10 and a half and 11 and a half years of age, there's a group of, and the size is encoded in this corner over here in terms of number of records. So the largest one is 12 records in that bubble. The smallest one is 2 records in that bubble. So this is again representing information that says how many records of individuals are there. If you're doing epidemiological studies, something like this would be very useful to use to represent information. Again, these are just different ways in which people have come up with of representing information. You can leverage that as you represent your own information. It's just that now you have the set of tools to play with and represent information in the way. And all I did was go to the gallery, right? So I went to the Altair gallery and copied and pasted code and adapted that code for my data set at hand, which I read it through pandas. So that's what makes it very interesting and exciting to be able to reuse things and represent your own information through them. Now the choice of how you choose, that I leave up to you.